Students, now let us see the formal charge from the Narayana NEET book only. Okay, so what is formal charge? Let us read out the statement and then we will be able to answer one by one, student. Okay, so firstly, when you are going to understand the formal charge, student, so you will find formal charge is a factor based on a pure covalent bond formed by the sharing of electrons pairs equally by neighboring atoms. Okay, so again you read out, student, the formal charge is fixed factor based on or pure covalent bond. Factor based on a pure covalent bond. Okay, what is factor based on pure covalent bond? Formed by sharing of electron pair equally by neighboring atom. Okay, let us see another statement, it might clear. Formal charge may be regarded as the charge that an atom in a molecule would have if all the atoms and the same electronegativity. It may or may not be represent the real ionic charge. What is meaning of this line, student? Let us try to understand. They are saying if you are ignoring the electronegativity, if you are ignoring the electronegativity of hydrogen and chlorine, in that case how much charge it is occupying, okay, how much charge it is occupying each atom, that is what is known as formal charge. Again you read out, formal charge may be regarded as the charge that an atom in a molecule would have if all the atoms of the same electronegativity, of all the atom, it may or may not represent the real ionic charge. Means like that it is having the minus charge, it is a polar covalent bond, but they are not talking about that. They are saying if it is the same electronegativity, in that case how much charge is coming, that is what is known as formal charge. Now let us read out another statement. In case of polyatomic ions, the net charge is possessed by the ions as a whole and not by a particular atom. Means that is whatever the charge will be there on the ions, students, that will be as a whole, it will be as a whole, not on the particular atoms. It is however feasible assign a formal charge on the atom in a polyatomic molecule or ions. Let us read out another statement, another slide. Okay, this is not too much tough, students. Initially it will look like tough, but it's quite easy only. The formal charge of an atom in a polyatomic molecule or ion may be defined as the difference between number of valence electron of that atom in an isolated free state and that number of electron assigned that atom in a Lewis structure. Okay, so here they are saying that is formal charge. QF, Q means charge, F means formal. Na minus NLP minus 1 by 2 n bond pair. So there is QF means formal charge. Na means number of electron in the valence shell in free atoms. Nm number of electron belonging to the atom in the molecule. NLP means number of electrons in the shared pair of electron, that is number of electron in lone pair. NPP means number of electron in bond pair respectively. So students, to answer this one, formal charge, we can write the little, summarize the formula for the formal charge. If you are writing the formal charge, student, formal charge, that formula will be able to answer any of the question. Formal charge is equal to valence electron of that atom. That atom means what, student? The electron which you are going to calculate, and minus what is, student? Non-bonded electron, that is what is minus number of non-bonded electron of that atoms, and finally minus what will be bonded electron by 2, minus bonded electron by 2. So this will be this is the whole as a formula of the formal charge. Okay, so student, let us see the one problem. The Lewis dot structure of pH3 is like that, pH3. Okay, and they are saying calculate the formal charge of P. So how can you pH3, if you see, student, if you are going for pH3, here is pH3. Okay, they are saying that is phosphorus. If you talk about, so phosphorus, how many valence electron, student? If you are going the phosphorus valence electron, so valence electron 2, 8 and 5. 8 to 10, 1, 5. and hydrogen is that is only 1. So there, if you are going to draw the formal charge of phosphorus, student, how can you draw the firstly Lewis structure you draw? So 1 2 3 4 5. Hydrogen, if you are going, student, hydrogen, how many electrons are there? They are also having one electron. So if you see, this is the formation of like that covalent bond is forming. Up now what they are saying is, student, equal to, we can write here is lone pair electron, and here is hydrogen, here is hydrogen, and here is one more hydrogen. अब student, they are saying calculate the formal charge on phosphorus. So formal charge on phosphorus, if you want to calculate, student, so how can you calculate? Here I am doing formal charge on phosphorus. So Fc on P, how much what was the formula, student? The valence electron minus non-bonded electron, non-bonded electron minus what is bond pair upon, okay, bonded electron, you can say bond pair, or bonded, you can say bonded electron by 2, bonded electron by 2. So here number of valence electron or phosphorus, how much we wrote, student? 5. Okay, so this is 5. Number of bonded electron, how many are there? 2 to 4 to 6. So that is, this is the negative charge, negative sign, everywhere negative sign is there. So minus 6 minus bonded electron by 2. Bonded electron by 2, student, how many bonded electron are there? 1 2 3 4 5 6. Student, here is non-bonded electron, this is non-bonded, sorry, this is minus non-bonded electron. So non-bonded electron is how many, student? Here in this case, how many non-bonded? 2 only. So 5 minus 2 minus bonded electron by 2. So 2 to 4 to 6, 6 by 2. So how much coming, student? 5 minus 2 minus 6 by 2, 6 3. So 3 to 5, 5 minus 5, 5 minus 5, how much is coming? 0. Similarly, here in the question they have already they have solved, student. 5 is number of valence electron. Okay, so 5. Number of non-bonded electron, so that is how many? 2. Number of bonded electron by bond pair by 2, so 6 by 2. So how much? 5 minus 5 by 0. So that is I solve also. Here is how much, student? 5 minus 5 equal to 0. Let us better to understand by taking other example. Formal charge on oxygen atom of ozone. So ozone molecule is there, student. Here is the Lewis dot symbol they have drawn out, student. So they are going to calculate the formal charge. अब now O3 molecule there, student. You put the, here is O. So how much? 1 2 3 4 and 5 6. Here is 1 2 3 4 5 6, and this is 1 2 3 4 and 5 6. So how this is structured? This is octet is completing. Okay, and here is also, this also completed the octet, but here is the, it is going like that. So means here the sharing is less, student. So when you are going to calculate the bond pair, suppose this is the, if you are doing the diagram, O double bond O, and here is single bond O, and here is lone pair electron, this is lone pair, this is lone pair, and this is the 6 electrons are there. So if you are considering this is 1, this is 2, and this is 3, you can check it out what are they have considered, which one is 2 1 3, student. 2, this is the, no, this is I think 2 in the 1, and this is the 3, 2 1 3. So this is the 1, this is 2, and this is 3. Now Fc on oxygen 1, Fc on 1 oxygen. So Fc on 1 oxygen, how to calculate it, student? Fc oxygen number 1, Fc oxygen valence electron, okay, student, minus non-bonded electron minus bonded by 2, bonded electron by 2. So student, valence electron in the oxygen atom is always how many, student? That is the 6 valence electron minus number of bonded electron. If you are calculating, how many are there, student? 2 to 4 to 6. So 6 is there, 6 is, no, oh sorry, the number of non-bonded electron. So how many non-bonded electron? 2 non-bonded electron minus 2 minus what is bonded electron? Here is, you see, student, 2 to 4 and to 6. So 6 by 2. So how much coming, student? 6 minus 2 minus 3. So how much coming student? Plus 1. So that is oxygen number 1, that is the formal charge is coming how much student? Plus 1. You can check out student how they have calculated. This is the formal charge. So 6 minus 2 minus 6 by 2, that is again coming plus 1. That is correct only. Now formal charge on O2, oxygen 2, second oxygen. So for this one, Fc, how to calculate? Valence electron C 6, non-bonded electron. If you check out student, how many were non-bonded? 1 2 3 4. So non-bonded electron 4 minus bonded electron, how many are there? 2 2 4 by 2. So that is 4 by 2. How much coming student? 6 minus 4, 2 2 ja 4 minus 2. So 4 minus 4, how much? 6 minus 6, how much coming student? 0. So that is for this one, how many charge is coming student? 0. Okay, so here you can show 4, here also 0 is coming. Now lastly you check out, that is O3, third oxygen, O3. So for third oxygen student, Fc is equal to valence electron is 6. Okay, and that is how many bonded electron? You check it student, bonded electron only 2 student. You see this is being shared. So bonded electron only 2 minus non-bonded electron 2 to 4 to 6, 6 by 2. So 6 by 2. So how much coming student? 6 minus 2 minus 3. So how much coming student? That is 6 minus 5, that is plus 1. Here is plus 1. So you check it out student, how much is coming. Here is something is mistakes student. Here is how we have calculated non-bonded electron, how much we put out this for O3 non-bonded electron 2 to 4 to 6 are there student. Little mistake we have done, little for this question we did the mistake student. Okay, so how we are going to do? See, number of valence electron is 6. Okay, and minus non-bonded electron is also 6. You can add out, you can check 2 to 4 to 6. So that is 6 minus 6, and minus bonded electron by 2. How many bonded electron? 1 2. So that is 2 by 2. So 2 by 2. So how much? 6 minus 1. So 6 minus 7 is equal to how much? Minus 1. So this is how much coming? For this one it is coming minus 1. So that is also correct. So this is how we are going to calculate the formal charge. Next point you read out student. Next slide what they are saying. The formal charge on an atom may or may not be same. It changes with the structural environment of the atom in a molecule. Means when the structure is changing, formal charge will also change. In resonance structure, electronic environment changes, hence the formal charge also may change. Resonance structure of N2O, they are saying. This is the one structure, that is another structure. So here is the formal charge, that is this is coming, and that is this is also being changed. I am not calculating, you can easily calculate. Formal charge represent the tendency to build up positive or negative charges. Okay, next slide. The lowest energy structure is the one with the smallest formal charge on the atom. The most stable structure is the one which has the smallest formal charge on the atom or zero formal charge on the atoms. Okay, now next one student, that is we are going to understand, that is the formal charge, formal charge. Okay, this you don't consider, better we can calculate this one. Formal charge in this molecule, one molecule they have given a student, and they are asking, that is calculate the formal charge. So this is the structure they have given a student. Here is hydrogen, there is hydrogen, here is hydrogen. Structure already given a student. Here is ozone. So this is the 6 electrons are there student, and they are saying that is calculate the formal charge. Here is the single bond is there. Calculate the formal charge they are talking about in this molecule. Calculate the formal charge of the carbon, oxygen and hydrogen. All the three places we have to calculate the formal charge. Now student, all the three hydrogen atoms are equivalent, therefore have the same charge in neutral. The oxygen atom bears the bulk of the ions negative charge. The sum of the atomic charges is the -1 they are saying student. Let me check out. For oxygen, if you talk about student, for this one, so Fc, if you are calculating, what is the formula? Valence electron minus non-bonded electron minus bonded electron by 2. So NBE or BE by 2. So valence electron, how many are there, student? 6. Non-bonded electron, how many are there, student? 2, 2, 4, 6, that is 6. A minus bonded electron, how many? This bond is one bond, so that is 2 electron, 2 by 2. So 6 minus 1, that is 7. How much is coming? Minus 1. So formal charge, how much they have wrote, student? Minus 1. Formal charge on oxygen we need not to calculate, it is the, if you are calculating the formal for charge of oxygen, it will be 0 hydrogen. If you want to calculate, you let us calculate for hydrogen. So hydrogen, Fc for hydrogen, how many will there? Valence electron 1 minus non-bonded electron 0 minus bonded electron, how many? 2 electron. This single bond, that is 2 by 2, that is how much? 1 minus 0 minus 1, so how much coming? 0. So for hydrogen formal charge is 0 and for oxygen minus 1. If you are taking another example, that is this compound is there, they are saying they calculate the formal charge on carbon. This molecule I am little changing, student, that is I am putting in the form of the Lewis dot structure. This is in the bond line formula. So if you are calculating this, they are saying to calculate the formal charge on the carbon. Okay, 3 bond are there. If you want to calculate the formal charge, so Fc on C. Okay, how to calculate, student? That is valence electron, how much? 4 minus, okay, minus non-bonded electron, here they are not showing non-bonded electron, that is 0. Okay, and then they are saying that is bonded electron, how many are there, student? Total bonded electron 2 to 4 to 6, 6 by 2, so how much coming? 4 minus 0 minus 3, so how much coming, student? Plus 1. So here you can see plus 1, hydrogen is 0. So like this you will be able to calculate, student, plus 1. Here is, there are so many questions I have taken. You can pause your screen, okay, and then you try to solve for the BH4, and then you can solve for the this compound. For each compound you can stop your slides and then you try to solve it out, student. You will be able to understand this concept. Here is 6 number. So many problems I have taken, student, in this. Here is also this. So you will be able to solve, student, but if you need to give little time. The same formula you have to follow for this one also. One more. Okay, 9 questions are there. You can slowly try, student. Thank you so much for watching, friends.